So let's look at a couple of more examples of related rates. And these are the ones that are usually pretty difficult to get a handle on. All right, so we have two cars. One travels south at 60 miles per hour. So we have one going south at 60 miles per hour. And we're going to call that y. Y is going to be the distance. Y equals distance traveled. All right. And then the other travels west at 25 miles per hour. So west at 25 miles per hour, this we're going to call x. So x is distance traveled by second car. All right, at what rate is the distance between the cars increasing 2 hours later? So what rate is the distance between the car changing 2 hours later? The distance between them is there. It's d. So I'm going to call that z. I could use d, but I'm going to take a derivative and it's going to, the d's are going to conflict. The one traveling south at 60 miles per hour, that tells us that y is changing, so dy over dt is going to be 60 miles per hour. And the one traveling at the second one is 25 miles per hour. So what that says is that dx over dt is 25 miles per hour. Okay, so it says at what rate is the distance between the cars changing? So what we need, we need to find dz over dt when t is 2. So what's happening is the green line is changing and the red line is changing, and we have to find out how fast the yellow line is changing as those two are changing. So we need to get a relationship between z, x, and y. So the first thing is find a relationship between z, x, and y. Well, it's a right triangle, right? So we have x squared plus y squared equals z squared. Now they're all changing. So when we take the derivative with respect to t on both sides, we get 2x dx dt plus 2y dy dt equals 2z and then dz dt. Now we can take out a 2 from everything, so we get x times dx dt. Just as similar. Now all we have to do now is plug in what we've got. So let's see, it says 2 hours later. So 2 hours later, let's see what z and x and y are going to be. X is going at 25 miles per hour. So 2 hours later, so when t is 2, this implies x is 50. When t is 2, this implies y is, let's see, we're going at 60 miles an hour, this would be y is 120. And so when we do the Pythagorean theorem on this, we get 50 squared plus 120 squared equals z squared. And so z is going to be equal. So we need all these quantities in our little formula down here. Show you right here. So x is going to be 50. dx dt is 25 miles per hour. Plus y is going to be 120. So it's 120. And then y is 60 miles per hour. And then z is 130. And we don't know what dz dt is. Right? And so when we do the math here, we get 65 or 65 miles per hour. And that's the answer. So basically what we did here, and this is really important that you understand this, is we looked at the problem and we noticed what the calculus is, and so the calculus is every time it says rate or travels out miles per hour, that's a rate. 25 miles per hour, that's a rate. And then you get, you draw a figure, and then you get an equation that relates all of the quantities in the figure together. We did that right here. This was key to doing the problem. All right, so let's try this again with another problem. So read number 32 real quick, number 32, and get up to speed. So it says example 2. Example 2 just has this figure with it. All right, so what I'm going to do is I'm going to make this a little bigger, and we're going to work with this. How fast the angle between the ladder and the ground? The ladder and the ground, so let's call that theta. Changing when the bottom of the, so how fast is it changing? So I'm going to immediately d theta dt. This is what I need to find. All right, when the bottom of the ladder is 6 feet from the wall. So the bottom of the ladder is x. So when x is 6. So the ladder is sliding to the right, and so x is changing. So apparently we have a dx dt going on here. X is changing, and y is also changing, dy dt. So we have a similar situation as the previous problem, where we have x squared plus y squared equals 10 squared. All right, and then when the bottom of the ladder is 6 feet from the wall, so when the bottom of the ladder is 6 feet from the wall, that's 36 plus y squared equals 100. So this means that y, 100 minus 36, 64, y has to be 8. So we got a 6, 8, 10 triangle going on here. All right, so 8, 6, and 10. So we're supposed to find how fast the angle is changing. So the angle can be related to x as, let's see, the cosine of theta is x over 10x. All right, so notice what I did here. I found a relationship between the quantities that I have and the quantities that I need. So let's see what we got here. When we take the derivative with respect, let me change the sides here. It's a little easier to read. When we take the derivative with respect to t on both sides, we get negative 10 sine theta d theta dt there. Now, we need to find d theta dt when x is 6, but the problem is we don't have dx dt. The problem actually states that the rate that the ladder is sliding away from the wall is 1 foot per second. All right, so I need to incorporate that into this. So we have 1 equals negative 10 sine of theta and then d theta dt. Now, I don't know what theta is at that point, right? When the x is 6. Well, when x is 6, we have sine of theta is cosine of theta. Cosine of theta is 6 over 10. And so theta is inverse cosine of 3/5. All right, and when you do that on a calculator, you get about 53.1 degrees. And so when you take the sine of that, you get 0.8. I guess we could have done this. This is 8, this is 10, and so the sine of theta is 8 over 10. All right, so we get 1 equals negative 10 times 0.8 d theta over dt. All right, and so looks like d theta over dt is going to be negative 1 over 8 radians per second. It's radians, right? Or negative 0.125 radians per second. So if you want to convert that to degrees, you would multiply this by 180 over pi radians. And so you'd get about negative 22.5 degrees per second. So let's see if that makes sense for the problem. Your theta value is getting smaller and smaller as x is moving to the right. Yeah, as the point that ladder point there is moving to the right. As it's moving to the right, theta is getting smaller and smaller by 22.5 degrees per second. All right, so now let's look at number 33. All right, so we have a ladder, and it's sliding down a wall, a vertical wall at a rate of 0.15 meters per second. So if we call this guy here y, and this x, it says it's sliding down the vertical wall at a rate of 0.15, so dy over dt, y is getting smaller, so that's negative 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters from the wall, so when x is 3, it slides away from the wall at a rate of 0.2, so dx over dt, this is positive, is 0.2 meters per second. All right, how long is the ladder? So we have to find L. Let me use Z again. So Z is length of ladder. All right, so we know that x squared plus y squared equals z squared. It's a right triangle. Notice what I did here. I got all the quantities related into one equation, related rates, how the rates are related. And so I guess I can take the derivative with respect to t everywhere since they're all changing. So I get 2x dx dt plus 2y dy dt, and then equals 2z dz dt. And then I can cancel all the 2's out. So they're all gone. And now one thing I need to note here is that this guy right here is equal to 0 because the length is constant. The length is a constant. So what we have, actually, this becomes much easier. We have x times dx dt plus y times dy dt equals 0. And so when we plug in our values for that are given up here, we get y equals 4. All right, so then when y is 4 and x is 3, you get 3 squared plus 4, I'm using this equation here, squared equals z squared, so that must mean that z equals 5. And that is the right answer. There you go.